Hello students, in this session we will discuss slope and deflection of a beam by strain energy method using first principle. So first of all we will discuss equation to calculate deflection and slope of a beam by strain energy method, and then we will solve a numerical to calculate deflection and slope at a given point using the method. So let's discuss equation to calculate slope and deflection by strain energy method. So here this is the equation to calculate deflection at a given point. So deflection delta is equal to 1 upon EI integration of mx into del mx by del p dx. Here limit will be 0 to L. We will use this equation to calculate deflection at a particular point in a beam. Similarly, we can use the equation to calculate slope at particular point of a beam, which is theta is equal to 1 upon EI integration of mx del mx by del m into dx. Here limit is 0 to L. So let's solve a numerical. Here one cantilever beam AB is given. Total length of this beam is 4 meter and the beam has fixed end at point A. The beam carries 140 kilonewton load at point C, which is 3 meter away from point A. The beam also carries 130 kilonewton load at point B, which is 4 meter away from point A. Now we need to calculate slope and deflection at point B for the given beam. Value of I is given, which is moment of inertia, is equal to 5 into 10 raised to 8 mm raised to 4, and value of capital E, which is Young's modulus of elasticity, is 2 into 10 raised to 5 Newton per mm square. So let's solve numerical. So we will first calculate deflection and after that we will calculate slope at point B. For calculation of deflection, here we need to assume or consider that this 30 kilonewton load is equal to P. Now, we will calculate mx and del mx by del P for the segment BC and segment CA separately. So let's start with segment BC. For segment BC, B will be the origin, and if I consider B as 0, then limit will be 0 to 1. Now for calculation of mx, I am taking one section at point x meter from point B, and I will calculate moment about this section line. So this point load P will generate clockwise moment about this section. We are calculating moment from right hand side, so we will consider all clockwise moment as negative. So moment of this point load P about this section line is equal to P into X. Okay. So here I am considering minus sign for clockwise moment. Okay. Now del mx by del P is equal to minus X. Here we can simply put the value which is in multiplication of P. Now let's calculate mx and del mx by del P for segment CA. So for segment CA, origin will be C and the limit will be 0 to 3. Okay. Now for calculation of mx, here again I am considering one section at a distance x meter from point C, and I will take moment about this section line. So here this point load P will generate clockwise moment about this section line, which is equal to P into x plus 1. Again the moment generated is clockwise in nature, so I am taking it minus. And this 40 kilonewton load will generate clockwise moment about this section line, which is equal to 40 into x. So it will be minus 40 into x. Now del mx by del P is equal to, here in multiplication of P it is minus x plus 1. Okay, so del mx upon del P for segment CA is equal to minus x plus 1. So Let's calculate deflection at point B using equation. So here is the equation. Delta B is equal to 1 upon EI integration of mx del mx by del p into dx. Limit 0 to L. So for that, we will apply the equation to segment BC and CA separately, and then we will add it. So delta B is equal to, for the first segment BC, 1 upon EI integration of, here for segment BC, mx is equal to minus p into x. So here I mentioned minus p into x. Now for segment BC, del mx by del p is minus x. So here I mention minus x into dx. For section BC, limit is 0 to 1. So here I mention limit of integration 0 to 1. Now equation for segment CA is equal to plus 1 upon EI integration of, here mx is equal to minus p in bracket x plus 1 minus 40 into x. So here I mentioned the same. And del mx by del p is equal to minus x plus 1, okay, into dx. Here for segment CA, limit is 0 to 3. So limit of integration for this 0 to 3. Therefore, delta B is equal to, here I simply multiply the values. Okay, so delta B is equal to 1 upon EI integration of P into x square into dx, limit 0 to 1, plus 1 upon EI integration of P into x plus 1 whole square plus 40 into x plus 1 in bracket into dx. Therefore, delta P is equal to 1 upon EI integration of P into x square dx plus 1 upon EI integration of, here factor of x plus 1 whole square is x square plus 2x plus 1 into P plus 40 into x in bracket x plus 1 into dx. Therefore, delta B is equal to 1 upon EI integration of px square into dx plus 1 upon EI integration of px square plus 2px plus p plus 40 into x square plus 40 into x into dx. Therefore, delta B is equal to, now integration of this p into x square about x is equal to p into x cube by 3 into 1 upon EI plus 1 upon EI, and integration of this bracket with respect to x is equal to p into x cube by 3 plus 2p x square by 2 plus p into x plus 40 into x cube by 3 plus 40 into x square by 2. Here limit is 0 to 3 and in first equation limit is 0 to 1. Now let's substitute value of P is equal to 30 kilonewton. Okay, so in the beginning we assume that P is equal to 30 kilonewton. Here for this equation upper limit is 1. So I am substituting x is equal to 1 and P is equal to 30 in this first equation. Therefore delta B is equal to 1 upon EI 30 into 1 cube by 3. Now for the second equation, upper limit is 3. So I am substituting x is equal to 3 and p is equal to 60 in the second equation. Therefore, it is 1 upon EI 30 into 3 cube by 3 plus 2 into 30 into 3 square by 2 plus 30 into 3 plus 40 into 3 cube by 3 plus 40 into 3 square by 2. Therefore, delta B is equal to 1 upon EI into 10 plus 1 upon EI in bracket 270 plus 270 plus 90 plus 360 plus 180. Therefore, I am getting delta B is equal to 1180 kilonewton into meter cube upon EI. Now, I am converting 1180 kilonewton into meter cube into Newton into mm cube. Therefore, I am multiplying 1180 with 10 raised to 12. Now value of E, which is given, 2 into 10 raised to 5, and value of I is also given, it is 5 into 10 raised to 8. So I am getting delta B is equal to 11.8 mm. I am getting this value positive. It means we can say that the beam is deflected in downward direction at point D by 11.8 mm. Now let's calculate slope at point B. Okay, so for calculating slope at point B, we need to apply fictitious moment m is equal to 0 at point B. So here in this figure you can see that I have applied one moment m is equal to 0 at point B. Here we will calculate mx and del mx by del m of segment BC and CA separately. So let's start with segment BC. For segment BC, origin will be B and limit will be 0 to 1. Now for calculating mx, I will take section at x meter away from point B in segment BC and taking moment about this section line. So the fictitious moment is clockwise in nature, so it will be minus m. Now this 30 kilonewton load will also generate clockwise moment about this section line, which is equal to minus 30 into x. Now del mx upon del m is equal to minus 1. Here multiplication with m is minus 1, so I am simply putting it minus 1. Now let's calculate mx and del mx by del m for segment CA. For segment CA, origin will be C and the limit will be 0 to 3. Now for calculating mx in segment C to A, I am taking one section at a distance x meter from point C and will calculate moment about this section line. So similarly, this moment will be minus n. Now this 30 kilonewton load will generate moment is equal to 30 into x plus 1 about this section line. Again, the generated moment is clockwise in nature, so I am putting minus sign over here. Now, moment of this 40 kilonewton load about this section line is equal to 40 into x. Okay. Now, del mx upon del m for this condition will be again minus 1 because in multiplication of m, here it is minus 1. Okay. Now, let's calculate theta b using equation. So, here is the equation. Theta b is equal to 1 upon EI integration of mx into del mx by del m dx, here limit 0 to m. Similarly, as we did earlier, here we will apply equation for segment BC and segment CA separately and then we will add both. So, theta b is equal to, for segment BC is equal to 1 upon EI integration of, now here in segment BC, mx is minus m minus 30 into x. So here I mention mx into del mx by del m in segment BC is minus 1. So here I put minus 1 into dx. Limit for segment BC is 0 to 1. Now, for segment CA, the equation will be plus 1 upon EI integration of, here mx is minus m minus 30 into bracket x plus 1 minus 40 into x. So I mention over here. Here, for segment CA, del mx by del m is equal to minus 1 into dx and limit for segment CA is 0 to 3. Now, therefore, theta b is equal to 1 upon EI integration of m plus 30x dx limit 0 to 1 plus 1 upon EI integration of m plus 30x plus 30 plus 40x into dx, here limit 0 to 3. Therefore, delta b is equal to 1 upon EI. Now, integration of this bracket with respect to x is equal to n into x plus 30 into x square by 2. Here, lower limit is 0 and upper limit is 1. plus 1 upon EI, integration of this bracket with respect to x is equal to m into x plus 30 into x square by 2 plus 30 into x plus 40 into x square by 2. Here limit is 0 to 3. Now let's substitute m is equal to 0 in this equation. So I am getting theta b is equal to 1 upon EI, moment is 0, that's why 30 into x square by 2, limit 0 to 1, plus 1 upon EI, again moment is 0, that's why 30 into x square by 2 plus 30 into x plus 40 into x square by 2. Here limit is 0 to 3. Therefore, theta b is equal to 1 upon EI 15x square, limit is 0 to 1, plus 1 upon EI 15x square plus 30x plus 20x square, limit 0 to 3. Now theta b is equal to 1 upon EI. Here upper limit is 1, so I am substituting x is equal to 1. So it is 15 into 1 square. Plus 1 upon EI, here upper limit is 3, so I am substituting x is equal to 3. So 15 into 3 square plus 30 into 3 plus 20 into 3 cube. Therefore, I am getting theta b is equal to 1 upon EI into 15 plus 1 upon EI into 135 plus 90 plus 180. Therefore, theta b is equal to 1 upon EI into 420. Here I am getting value in kilonewton into meter square and converting it into Newton into mm square and multiplying 420 with 10 raised to 9. Now value of E and I, it is given 2 into 10 raised to 5 and 5 into 10 raised to 8. So I am getting theta b is equal to 0.00420 radian. Okay, so we have calculated slope and deflection at point B. This is end of the session. In next session, we will calculate one more numeric. Thank you.